This is K. Ashish studying in second year of third STEM. Now I would like to talk about my topic of signals and stochastic process subject. And the topic name is autocorrelation of discrete time random process. Here coming to the introduction of autocorrelation. Autocorrelation measures how a signal correlates with itself over different time lags. It's a crucial tool in understanding the properties of random processes. This presentation will explore the definition, properties, and applications of autocorrelation. Moving on to the definition of autocorrelation. The autocorrelation functions quantifies the correlation between a process at different time intervals. Mathematically, for a discrete time random process, the autocorrelation at lag is defined as the given expression. ACF provides insights into the structure and predictability of the random process. This is the definition of autocorrelation. Now moving on to the next slide, we have properties of autocorrelation. The autocorrelation function is symmetrical and meaning is the given expression. It is also non-negative definite, indicating that for any infinite set of time lags, the associated covariance matrix is positive semi-definite. Additionally, the ACF at lag 0 equals the variance of the process, and it shows the given expression. Here we can see how the properties of correlation takes place in the given figure. Now moving on to next slide, here we have about stationary and autocorrelation. A process is weakly stationary if its means and variance are constant over time. For weakly stationary processes, the autocorrelation depends only on the lag, not the specific time. This property simplifies the analysis of random processes significantly. Here we can see the inputs of stationary and autocorrelation. Now moving on to the next slide, here we have about types of autocorrelation functions. There are two primary types of ACFs. ACF stands for autocorrelation functions, theoretical and empirical. Theoretical ACFs are derived from mathematical models, while empirical ACFs are computed from observed data. Understanding both types is essential for modeling and analyzing real-world processes. Here we have about empirical evidences example, survey data, cross-sectional data, observational data, and cultural artifacts. Data systematically collected samples populations that provide insights into opinions, attitudes, and perspectives of the population. Here this is about the empirical evidence and the examples and types of autocorrelation functions. Moving on to next slide, we have calculation of autocorrelation. Autocorrelation function can be estimated using the data through the formula. This formula for the number of overlapping samples to provide an unbiased estimate. Proper estimation is crucial for accurate analysis and interpretation of data. Here we can see how autocorrelation is used in an example. Now moving on to next slide, here we have about applications of autocorrelation. Autocorrelation is widely used in time series analysis to identify patterns and trends. It is instrumental in signal processing for detecting periodic signals in noise. Furthermore, it plays a significant role in econometrics for modeling and forecasting economic indicators. Here we can see the autocorrelation patterns and trends. This is how it goes on autocorrelation. Now moving on to next slide, we have about autocorrelation in signal processing. In signal processing, autocorrelation helps in identifying the presence of a signal within noisy data. Techniques like match filtering utilizes the autocorrelation to improve signal detection. This application is essential in communications and radar system because the autocorrelation of signal with presence of noisy data. Techniques like matched filtering utilizes autocorrelation to improve signal detection. This is mostly used in communication radar and communication systems, where the communication is the main thought of the process. Here, moving on to next slide, we have limitations of autocorrelation. Autocorrelation can be misleading in non-stationary processes where properties change over time. It may fail to capture complex dependencies in high-dimensional data. Therefore, caution must be exercised in interpretation, especially in real-world applications. Here we can see how the non-stationary behavior of autocorrelation takes place, taken from the website Investopedia of limitations of autocorrelation. This is about the limitations of autocorrelation. Moving on to next slide. Here we will come to know about cross correlation versus autocorrelation. While autocorrelation examines a single process, cross correlation assesses the relationship between two different processes. The cross correlation function is defined as the given expression. This distinction is vital for multivariate time series analysis. Here we would like to know about source signals and their graph and the types of it. This is about the cross correlation versus autocorrelation. Now moving on to next slide. Here we have about practical example of autocorrelation. Consider a time of series of monthly temperatures. The autocorrelation can reveal seasonal patterns. By calculating the ACF, one can identify significant lags corresponding to seasonal cycles. This analysis is assisted in better climate predictions and understanding temperature trends. So this is the practical example of autocorrelation used in our daily life in knowing about temperature. Considering a month of temperatures of 12 months, we can conclude that the particular temperature is over a period of time in a particular month. So we can predict the temperature in the coming months and the coming over years. We can plan accordingly. That is the practical example of autocorrelation. Now moving on to next slide, we have about software tools for autocorrelation analysis. Several software tools including R, Python with libraries with like NumPy and Pandas and MATLAB facilitate autocorrelation analysis. These are the software tools which are used for autocorrelation analysis. Utilizing these tools can enhance the data analysis and interpretation of data assets. In previously, we have used this autocorrelation in our daily life, like knowing about the temperatures in our daily life. Accordingly, we plan our plans. That is why we have used in our software tools for autocorrelation analysis. These provide built-in functions to compute and visualize ACFs efficiently. Utilizing these tools can enhance the analysis and interpretation of complex data and makes our lives easy. Now moving on to next slide. Here we would like to know about the summary of key points of autocorrelation. Autocorrelation is a fundamental concept in the analysis of discrete time random processes. Understanding its properties and applications is crucial for effective data analysis in various fields. Careful interpretation of autocorrelation results in necessary to avoid misleading conclusions. Here we would came to know about the autocorrelation summary, and there are some more key points where it concludes about the autocorrelation in the analysis of discrete time random processes. Here we would know about the pattern identification. Autocorrelation reveals repetitive patterns such as periodicity in the random process. That is why autocorrelation is used. And in the memory process, high correlation at a random process has a strong memory or dependence between the value. And the another topic in the summary of autocorrelation is stationary insight. For WSS depends only on the lag, simplifies and statistical properties over time. And the another one is frequency analysis. Frequency analysis is the Fourier transformation of the autocorrelation function, gives the power spectral density showing the how signal is distributed across the frequencies. Noise and variance. At zero lag k equal to 0, the autocorrelation equals the variance of the process, providing a measure of intensity. And the validation of model. Autocorrelation helps in validating models as it compares the predicted and actual dependency structure in the process. Practical applications. It is vital for signal processing, econometrics, machine learning to analyze trends and detect anomalies of the time random discrete process, and the machine detect anomalies or process the data further. Here we could conclude about the autocorrelation is a fundamental concept in the analysis of discrete time random process. Understanding its properties and applications is crucial for effective data analysis in various fields. Careful interpretation of autocorrelation results in necessary to avoid misleading conclusions. So this is the summary of the autocorrelation. Moving on to next slide. We have completed the topic. Thank you.